In this bonus objective, we're just going to get some new definitions that kind of just show us some patterns that can happen with functions. All right, so in math, it's always useful to have patterns because you recognize some patterns can simplify some part of some process. So it's always helpful to recognize these patterns because at some point, it's going to make your life easier. All right, so the patterns we're going to look at are two things called even and odd, and they're just two properties that a function can have. All right, so the first one is even, and this says if I plug in the negative of some value, then I get out the same thing as if I had just plugged in the positive. All right, so an example of an even function, and the reason it's called even is because x squared is an even function or has an even exponent. Right? X to the fourth and x to the sixth would also be even functions. I would also get x squared. If I plug in negative 2 into x squared, I get out positive 4 because the two negatives cancel. And that's the same as I had plugged in positive 2. I also get out positive 4. All right, so whether I plug in the negative value or the positive value, I get out the same thing. All right, so this is an even function. All right, just the definition. An odd function is similar. So an odd function is going to be an example. These are not the only odd functions, but the examples are going to end up being like x cubed, x to the fifth, and x to the seventh, and so on. But here, you put in the negative value, and this negative kind of jumps out to the front. So putting in the negative value is the same as just making the positive value negative. All right, so let's look at an example. And let's start with 2. All right, so for negative 2, and we're going to cube it because we want to look at an odd function. So negative 2 cubed is 3 copies of negative 2. 2 of the negatives cancel, but we still have one negative kicking around. All right, that one negative is going to be there, and then 2 times 2 times 2 is 8. So if I plug in negative 2, I get negative 8. If I plug in positive 2, that's just 2 times 2 times 2, I get positive 8. Right. So when I put in the negative value, it's the same as just putting a negative value in front of the positive, right, as if I plugged in the positive one. Right, so odds are a little bit more difficult. Even if you plug in the negative, you just get the exact same thing. Odds, if you put in the negative, you just take the original and put a negative at the front. All right, so look at this graph. We have half of this graph graphed. What is the other half going to look like if it's an even function? So an even function, again, I'll just write the definition here. If I put in the negative value, I get out the same thing as the positive value. So for positive 1, I get out negative 1. So for negative 1, I'm also going to get out negative 1. All right, for positive 2, I get out 0. So for negative 2, I'm also going to get out 0. For positive 3, I get out 3. So for negative 3, I'm also going to get out 3. All right, so basically the same thing's happening on the left is happening on the right. And then that's always going to happen. All the negative values are the same as the positive values. I'm basically just going to get this picture. Just like that. All right, just a mirror image over this y-axis because everything on the left is giving me the same thing as everything on the right. All right, so that's how an even function is going to look. All right, what about an odd function? All right, when I put in the negative value, I get the opposite of the original. So in this one, I put in 1 and I get out negative 1. So when I put in negative 1, I'm going to get the opposite of negative 1, which is positive 1. So that's going to be there. On my original, when I put in 2, I get out 0. So when I put in negative 2, I'm going to get out negative 0, which is still 0. So I'm going to get that point there. When I put in 3 into my original, I'm going to get out 3. So if I put a negative 3 into my original, I get the same thing with a negative 3. So negative 3, negative 3. All right, so everything that I put in a negative, I get the opposite for, and it's going to end up giving me a picture that looks like this. And this one's not as easy to see kind of how the symmetry is, right? But if you kind of take the right-hand side and rotate it around, then you get the left-hand side. So as this part rotates around, it'll become there. This part becomes there. This part would rotate. All right, so I'm just rotating around the middle of the graph, and I get the second half. All right, so in summary, even functions are symmetric about the y-axis, so I kind of have that vertical line. If I have half of the graph drawn over here, I just repeat the same thing over there. Right. Odd functions are symmetric about the origin, so if I have my axes and the graph, I just rotate that around, so any upward part is going to be a downward part, any downward part is going to be an upward part, and I'm going to get something like that. All right, so again, this kind of whole thing is rotating it around and becoming that. All right, so that's known as symmetric about the origin. All right, so if we're looking at a graph, now we can kind of look at the symmetry and determine it's even or odd, but we can't necessarily do that with an expression. So how do we figure out if an expression is even or odd? Or neither, because it's possible for it to be neither even nor odd. All right, but we have our definitions, even and odd. And if you look at both definitions, they start off with this negative x in the parentheses. All right, so the first thing I'm going to do is plug in negative x. All right, so if I plug in negative x, I'm going to get negative x raised to the fourth minus negative x squared plus 2. And the important thing to remember is a negative raised to an even power is positive, because all the negatives pair up. A negative raised to an odd power is negative, because all of them but one pair up. So a bunch of them pair up and cancel, but one of them doesn't. So negative x to the fourth is the same as just positive x to the fourth. Negative x squared is the same as just positive x squared, because the negatives are going to pair up because it's even. And if you compare this to our original, they're the exact same. So even though we put in negative x, we get back the exact same thing, and that means this function is even. All right, but for this one, we're going to try the same thing. Is this even or odd? So I'm going to put in negative x. Right. A negative to an odd power is negative. So negative x raised to the fifth is the same as negative x to the fifth. Right, minus 3. Negative x squared, 2 is even, so negative x squared is the same as just x squared. 2 times negative x is no exponent, it's just minus 2x. All right, so let's compare this to the original function. It's definitely not the exact same as the original, because here we start off with a positive x squared, and here we have a negative x squared. So it's not going to be an even function. But also here, this part is the same. So it's not an even function, and it's not the opposite of the original. So this one is actually neither even nor odd. It doesn't come out to a nice pattern. One thing changes and one thing doesn't. It's just neither. Now we'll do one more example. Oops. Negative x to the fifth minus 4 to the negative x cubed. Again, I'm just putting in negative x for all the x's. All right, negative x to the fifth, because 5 is odd, that's the same as negative x to the fifth. All right, negative x cubed, that's the same as negative x cubed, and minus 2x. All right, and these two negatives in the middle are going to cancel out. And how does this compare to my original? Again, it's definitely not the same as the original, because this original had a positive here and a negative there. Then it has a negative here and a positive here, and a positive here and a negative here. All right, so everything is the complete opposite of how it started. So I could factor that negative out and change everything back. And you can see this is my original function, which is an extra negative there. So this is negative fx, and that makes this odd. All right, so if everything is the opposite, it's odd. If everything is the same, it's even. If there's some mixture, then it's neither. So go ahead and try this on your own. All right, is this function even, odd, or neither? All right, and hopefully you get that it is even. Again, first step for all these problems is plugging in negative x. I bet negative x to an even power, the negative just goes away, and that happens twice. And if you compare this function to your original, you get the exact same thing. If you get the exact same thing, then it's an even function. All right, so for this learning objective, you're going to do a skill check, and it's basically going to be split just like the video was. You're going to have two examples where you have half of a graph, and you have to graph the other half based on if it's even or odd. And remembering that even functions are symmetric about the y-axis, odd functions are symmetric about the origin. And you're going to have two functions we have to determine if it's even or odd. So just like those last 4 examples we did, put in negative x and simplify to see what happens.